Hi, I'm Tony Fowle. This is just one video in a series of tutorial videos showing how to use my motorcycle setup software, which you can see more details of on my website at www.tonyfowle.com.
When working with a project, on the various analysis screens such as the front forks and the rear suspension, we can plot the results for the current project. Various characteristics are shown on predefined graphs. However, we often need to be able to compare one particular setup with another, the characteristics from different setups. And the software has built in a plotting module which allows up to 10 different cases to be shown on a single plot. Now this is very quick and easy to use, as we will see. Buttons to access this are available on several different screens. Here we have one on the opening screen, but the results screen of the rear suspension and front forks, for example, also have buttons labeled multi-plotting. Let's access it from the this button on the opening screen, for example. Here on the left we have the typical Windows folder selection system, and by default the data will have been saved in My Documents, Suspension Data and Kinematic Results. Here we have a list of ERD data files in the selected directory. Okay, when you save the results and come to plot them, you can choose other directories, but this is the default one. Let's just, all we have to do to be able to select a particular file for plotting is just click on it from this list of previously saved files. In this case, let's just pick these which I've saved from some earlier work. We'll pick 4 particular examples of the same basic system, and as you see, as we click on each one of these, it's added to our list down here. We can select up to a maximum of 10. If we try and go over 10, we get a warning message and we can't. Any here we can pick out of the list and delete by simply clearing the selected message from the list. Or if we want to plot from several different things, we can come back to this and clear all the files from the list and start again. Okay, so once we've selected our files, it's just simply a question of pressing the plot graphs button, and we have, in this case there was only 4 selected. We have our 4 graphs plotted. We can normally, if we're looking at the rear suspension results, for the x-axis we'd use the wheel displacement, which is the default one. It's at the top of the list of parameters. For the y-axis we can select various calculated parameters that have been saved previously, and it will just plot those parameters immediately. For instance, now we're looking at the shock displacement against the wheel displacement. Incidentally, if this legend for the different color lines is in the way of the graphs, we can just drag it to another part of the screen to put it out of the way, or we can toggle the legend on and off. Okay, the legend actually shows the file names that we selected. So if we select motion ratio, just click on that and it plots the motion ratio for the 4 different cases. The wheel rate, the effective spring rate at the wheel, for example, the force in the spring, the force at the wheel, as mentioned in the documentation. This is probably the most important parameter of all. We have forces at the pivot, and the vertical force, the horizontal force, etc. Here we can plot the differences in the anti-squat percentage or the anti-squat angle. This is a case where we might want to move that out of the way. Okay, as you can see, it's very quick and easy to select any particular parameter. On here we can toggle the legend on and off, as mentioned before. The scaling and offset is sometimes useful. For instance, say we were looking at the wheel rate. These are the actual values, but it might be useful to us to see them on a percentage basis. So for instance, say we wanted to make this 100% and everything else was based off that. we can see from the crosshairs at the moment that the y value is 14. So if we divide 100 by 14, I'm doing this off screen on a calculator as I'm speaking, and that's 7.143. So if we come into the scaling and offset screen, if I make this 7.143, we can elect maximum values of the x and y axis as well here. Okay, so we have a data scaling of that. What we now see is that this graph is plotted with the minimum being 100%, and we can very quickly see that it rises up to say 212, so we've got a little bit over a 2-to-1 ratio, but we can see on a percentage basis the characteristics of the other curves. So the scaling and offset can be quite useful in some cases. I'll just put that back to 1, and then we're back showing the real values. We've got various copy and print options. We can copy it to the clipboard if we want to paste it into a Word document, for example. If we were making a report, we could save the graphic to the file, or we can print the complete form. Version 1.22 of this software saw some enhancements to this plotting module. So let's add in 3 cases so that we can see what these enhancements do. In this case, let's look at the wheel rate plotted against a vertical wheel displacement. Here we see that each 3 cases got considerably different rate values, but we can change the rate values simply by changing the spring on the shock. So in some cases this doesn't tell us the full story of what we're interested in, which in many cases may well be how the rate varies over the range of wheel displacement rather than its actual value. So it's often useful to display curves like this on a percentage basis. So in this case, let's say that we're going to start off with an initial rate percentage of 100% at 0 wheel displacement. It's easy enough to calculate what that scaling value should be. We just divide 100 by the value at 0, which in this case is 16.6, and that would give us a scaling factor of 6.02. So it's the y scaling we want to change. I'll put in 6.02 here. I've previously calculated the values that are necessary for the other 2 cases. The second one was 4.55 and the third one was 5.26. So we just get a little notice here to warn us that the scaling and offsets are in action. And here we can see that all 3 curves now start off at 100%. We can also see, despite the fact that cases 2 and 3 look quite different before we applied the scaling, we can see that throughout their range, let me just move this to one side, that throughout their range they're essentially the same. This is simply because those 2 cases were an identical setup except for the spring that was added. Case 1, on the other hand, had a different physical layout, and so the way in which the rate changes over the range varies from cases 2 and 3. Now let's see a case where we may want to apply vertical offsets. So let's look at the wheel force. Now at 0 wheel displacement, this initial force is mainly controlled by the preload that we put on the spring, and so we can see that we've got different preloads in each of these 3 cases, but it may be useful to us to see what these curves look like with 0 preload. So if we just simply apply an offset to start all of those curves off from 0, then we can see what happens if we eliminated the preload. So let's do that. So it's a y offset that we're interested in. Number 1, we need to put in an offset of minus 414, which was its that's the cancelling value for the starting preload that it had. Number 2 was minus 525, and the third case was minus 444. So now we have got all of these starting with 0 preload, and we can see how the force varies throughout the range of wheel displacement. Another addition that we have is we can now toggle between a point and a line display, and again, just like with the line display where we can change the thickness of the lines, that also works to change the diameter of the points. This is often useful if we just want to zoom in on a small part of the curve, because then if we change over to the points, we can see how many data points we've got in the area that we're zooming. For instance, if we've only got 1 or 2 points within that area, we know that we're not getting very much detail on that curve. Let me just put that back to a line display. Now, a zoom feature has been added to the program, which we can do that by a normal Windows dragging procedure, but how it works in this case, if we draw a rectangle within the boundaries of some grid lines, it's the grid lines on the outside of the rectangle that we've drawn that will be the limiting borders for zooming in. We can do the drag the rectangle for the zoom parameters by holding down the control button and the left mouse button and then forming a rectangle. So in this case we'll zoom in on an area which is the same as the grid lines which are bordering the dotted area which I've just dragged out. So I'll let go of the control and the mouse button, and now we've zoomed in on that particular area. As I said before, we can toggle here to get some idea of how many data points we have within that zoomed in range. We can zoom in continuously. For example, if I just want to look at this little area here, sorry, I forgot to press the control button. Let's do that again. Okay, now we can see that we've zoomed in even more. But this is where the point option is quite handy, because it shows us just how many data points we have on that part of the screen. If we press the plot and refresh button, then that will give us the option to return everything back.
Well, that's it for now. To make sure that you don't miss any more of these tutorial videos on the motorcycle setup software, I suggest that you tick the like button on this one and subscribe to my YouTube channel, Motor Chassis. For more information about the suspension setup software and my book on chassis design, I suggest you visit my website at www.tonyfoal.com. Thanks for watching.